All right. So our next topic in Unit 9 is the main topic of Unit 9, and that is scatter plots. So today we're going to talk about what a scatter plot is and where they come from, and a few other things that are related to the idea of scatter plots. So let me give you an example. What if you were doing some bivariate data about height and weight? But before you try to come up with any jokes or anything about that, this data is going to be collected at a doctor's office by a doctor about the height and the weight of a bunch of kids who come in for their annual checkups. So I'm going to put weight here and height here, and we're going to have height on the x-axis and weight on the y-axis. And let's just say the first kid that comes in is 30 inches tall and weighs 40 pounds. And then let's say another kid comes in and they're 40 inches tall and 50 pounds. But then another kid comes in and they're also 40 inches high, but they weigh 60 pounds. It's interesting, but you could imagine that happening. Sometimes there's two kids that are the same height, but different weights. Okay, then some more kids come in, and there's one kid that's really scrawny and little, and they're short, and they're also kind of skinny and not very tall. And then you could have some other kids kind of coming in that are various heights and weights, like maybe a really tall skinny kid, or maybe just a really tall big kid that's like 71 pounds. That's pretty heavy. But what you see here is that the data, the bivariate data, is scattered all over the graph. And sometimes that happens. Sometimes data isn't linear. Sometimes it's scattered. So we call this a scatter plot because the data is scattered around the graph. Woo, scatter plots. Okay, now, what's the point of a scatter plot? Scatter plots give us a picture of how our data is arranged. And when I say picture, it really is a picture. It's a visual idea of what's happening with this data. And that picture might help us understand the data better. Like, for instance, in this case, you might look at how the dots kind of generally line up, and you might come to the conclusion that generally as children grow, they get heavier and taller. And that kind of makes sense, right? But what's up with this kid over here? This kid is one of the tallest kids in the group, but also one of the skinniest kids in the group. Well, that's not such a bad thing, right? But this kid is what we call an outlier. Outliers are pieces of data that don't follow the general trend. See how all the other dots make a nice line that kind of goes together? It's not exactly linear, but it kind of follows a linear trend. This one dot doesn't really fit in with that perfect kind of trend there, so it's an outlier. Outliers are abnormal. They're out of the ordinary, or they lie outside the norm, and since they lie outside the norm, we call them outliers because they lie outside of what's normal. So this kid's special, that's all. And it's good to be different, so be nice to those kind of kids, all right? So outliers. Now, we also need to talk about the idea of correlation. Correlation just means, how are the two variables related? Are they related with each other, co-related? So in this particular situation, the dots kind of go in an upwards direction, right? What we would have called increasing, or if we had found the slope of this line, it would have been a positive slope. So we call this positive correlation. If the dots seem to kind of line up in an upwards direction, that's called positive correlation. What positive correlation means is that as one variable increases, the other also increases, which is generally true about kids as they grow, right? As they get taller, they also probably gain weight. That's called positive correlation. Here's another example of positive correlation, and I'll make this one a little bit more personal. If I had bivariate data and one of my variables was the number of bacon cheeseburgers that I eat, and the other variable was my cholesterol level, the more bacon cheeseburgers I eat, the higher my cholesterol. That's positive correlation. They both increase together. Okay, how about this one? The number of times I post inappropriate tweets about One Direction, what? Don't judge. And the number of restraining orders? Well, if you post too many tweets, then you're going to get more restraining orders. I learned that one the hard way. But anyways, this is another example of positive correlation. Okay, they both go up together. So all I want you to do at this point is answer one question and then answer another one. First, try to think of another two variables that might have positive correlation. Another two things that could change, but when one increases, the other also increases, not decreases. And then, number two, what do you think negative correlation would look like on a graph? Try to sketch me a quick example. That's it. We're done. See you next time.